Alright guys, so now that you know how to declare an array and also you know how to initialize an array, that's time that we learn how we can access each of its elements. So first of all, we need to understand that an array is just a collection of elements. We also said that these elements are organized in some manner. How are they organized? Simply in some consecutive manner, simply one after the other. And we can refer and access any of these elements by using their, let's say, location within this given array. So we can say that every element in an array has its location, and this location is called an index. And in C language we say that the first element is located at index 0, okay? So at index 0 we have our first element, and the second element will be of course located under index number 1, and so on and so forth. You've got the idea, okay? So if you have an array with 5 elements total, then the last index will be, think about it for a second, okay, or just take a look at the screen right now, and you are right, the index of the last element, the 5th element in this array will be 4, okay? So the first element will be at index 0 and the last element will be at index size minus 1, the size of the array, which in this example is 5, minus 1, which is a total of 4. So that's how you find that's how you treat, or that's some guidelines, that the first element is at index 0 and the last element is at index size minus 1. Please note that indexes should always be integers, and also make sure that you do not exceed the size of the array when you try to access one of its elements. For example, if you have an array with 5 elements, then your last element in the array will be at index 4 and not at index 5. So make sure you're not trying to access different addresses that do not belong to you. Otherwise, if you don't pay attention to it, you may end up with an access violation error. And that's simply because your program is not intended for working with the address you're trying to access, okay? This value or data that is stored under index 5 does not belong to your program, and that's why you are going to get an access violation error. Just like in real life, don't try to access what's not yours. And because the compiler is not always going to warn you about your attempts to access things that do not belong to you, this responsibility is on you, the developer. So now we know that indexes specify the location of elements within the array. So let's create a simple array. Let's create it and initialize it, okay? So array initialization. So how it looks like. So first of all, you specify int, which simply tells what will be the type of all the elements inside of this array. Then you use the array name, square brackets to specify that it's an array, and in the curly brackets you specify all the values that this array will have, okay? We didn't even specify the size of the array, but it knows by itself how to fill up this array. So on the left side you can see the syntax in our C programming language, and on the right side you can see basically what happens behind the scenes, okay? How the array is stored in the memory. And now if we want to talk about how you can access one of the elements of the array or any of the elements in this array, you can simply do this by specifying the index of the element that you want to access in square brackets, okay? So you specify the array name. First of all, you specify the array name, and then you open square brackets and fill in the index of your desired element. And then of course you close the square brackets. So for example, we can see here that we use the test array we've initialized previously. This is the name of the array, and in the square brackets we use the number 2, the index 2, which simply says go to test array to location number 2 or to index 2 and take the value that is stored there, which in this case is just 3. So now once you know how to access any value within a given array, you can access, change it, modify however you like. You can read from the user using scanf function and so on. So how would you change the value of one of the elements? Basically what you have to do is to first of all you access the element by using the array name and its index. Okay, so let's say we want to access the last element and to change it to be 9. So that's how you access the last element. And now you can use the assignment operation to assign a new value to it. So for example, we will just use equals to 9. And what it will do, it will modify from 10 to just 9. Okay, so that's how you access and modify. That's an example of how you modify a value within a given array. And also we can do pretty much the same if we want to print out some value of some element within this array. So for example, we can print out the value of the first element of the array, and we just access it just like we've done it previously. So we specify the array name and the index we want to access, and then we simply access its value. So in this case, what will be printed is just 2, right? Because 2 is the value of the first element in this array. Okay, so now if we want to print out, I don't know, the second value in this array, the second element, we will use test array and index number 1, which will print simply 5 to the screen. Good guys. And now you know how to access, modify and print the values of elements within a given array. And now it's time to write a simple program that will create an array of, let's say, 5 grades, get the grades as input from the user, and find out what is the lowest grade in this given array. Let's just go over the code here line by line. So first of all, we include the standard input-output library. Then we start our main function, and now what we are doing is we declare an array of integers, and the name of this array is grades, and it's of size 5. And what we are also going to do is to create an I variable that will help us using the iteration, the loop, to read the values, the grades from the user at every time. And also what we are going to do is to create another additional variable called lowest grade, and it will store the lowest grade so far while we run our loop. So let's create our for loop, because we know it should be done only 5 times. So for I equals to 0, as long as I is less than 5, then on every iteration we are going to increment I by 1, and in the loop body we are going to specify this following message: enter grade number, and instead of this %d we are just going to specify I plus 1. So the first iteration will have enter grade number 1, enter grade number 2, and so on and so forth. And on every iteration we are going to read the value from the user, the grade he inserts, and store it inside its corresponding position, its corresponding location inside of this grades array. So we use the ampersand to specify the address where grades at the index I resides, and we are going to put inside this location, this element, the value that we've read from the user from the console application. So once we are done with our for loop, we are basically going to initialize, kind of set some value, some default value, which is a must step to the lowest grade. So we will assume that the lowest grade is our first grade that the user inserted. And then what we are going to do is to create another for loop, okay, that runs from I equals to 1 as long as I is less than 5. And we are going to see if there is any lower grade inside of this array of grades. And if that's the case, if we find that some element in this array is lower than the lowest grade so far, we are just going to update the lowest grade to be equal to this particular grade, because we are looking for the lowest grade inside of this array of grades. And once we are done with the second loop, we are going simply to print the lowest grade to the screen. So we know that at this point, at this printf line, we are over these two for loops, and we know that lowest grade, that this variable will hold the lowest grade in this grades array. So if we take a look at how some example, okay? So enter grade number 1, let's say 70, enter grade number 2, 60, 80, and let's say 90 and 100, okay? So after inserting all these grades, we will have an array of 5 elements, and the first element will be equal to 70, the second one to 60, 80, 90, and 100. This will be our array of grades. And now the second iteration is going to run and to find out what is the lowest grade inside of this array, and a corresponding message with your lowest grade is 60 will be printed to the screen, and we can see that it's exactly what we expected our program to find out, because visually we can see, right, because it's a simple program, that 60 is the lowest grade. Now, once you've got all your grades and you've found out what is the lowest grade, you may also want to print out all the grades to the screen, just to take another look at them, for example, okay? So how will you do it? How will you accomplish this task? Can you simply use just one printf line to print the whole array, something like this? Printf, your grades are %d, and specify grades, and we know that grades is an array. Come on, you can go and try this one on your own to run this command and see what happens. And basically what you're probably going to see is that not all the grades were printed out. We have a total of 5 of these elements, but only one strange value was printed. Maybe on your screen it's some other value, but it's still very strange why some strange value was printed out if we have some grades and it's 5 elements. So why is that? So if we take a look at the following array, let's say that these are the grades the user specified, we can clearly see that this number printed on the screen is actually not even a part of our array, okay? It's not a value, it does not represent any value. So what is this number? You see, when we declare an array or anything else, it will reside somewhere in the computer's memory. And it should have some unique address where, for example, it can be stored, okay, some unique place. So this way, the way we've just seen that we can print grades, how we've done it, we simply printed out the address of the grades array. And although that's nice that we can print the actual address in memory of a given variable of a given array, that's not what we wanted. That's not the way to print all the array's elements or values. So how should we do it? So there is no magic in C programming language. If you want to print all the elements of the array, you must go over each and every one of them. And this can be done using loops, alright? So first of all, let's use a for loop to iterate over all the elements of this array from index 0 up to index 4. 5 is not included here, right? And here we know that I will represent the index of each of the elements in this array, as well as it will also allow us to access any of them. So if we want to access and print the values, we can use that printf line, okay? So printf grades at the index I equals to the value at this particular index. So then on the first iteration, we are going to print grades at the index of 0 equals to 70. Then on the second iteration equals to 60, to 100, and then to 80, and so on until the last element, which is 90. Okay, so that's how you print all the elements of your given array. And it doesn't matter if this array is just an integer array or characters array or floating point array, the structure of printing all the elements of this array will be pretty much the same. And also, if you would like to print the elements of the array starting from the last element up to the first, and not vice versa, what would you do? So this approach of just starting from the last index and then decrementing one from the index going to the left by the index is very straightforward. In this case, we're simply going to print all the elements starting from the last index to the first one, and this index in our example is simply 4. So I hope that's clear to you guys. And now for the end, let's talk about how all the elements of the array are arranged. Basically, array is a consecutive sequence of elements. The name of the array in our example is grades, and it actually represents the address of the first element of that array. Right after the first element of this array lies the second one, in sort of a consecutive manner. So the addresses in memory of the elements of the array are simply organized one after another. You can see that the address jumps by 4, right? And the reason for that is because we have an array of grades, an array of integers. So we know that each element in this array is of an integer type, and we know that an integer is just 4 bytes. So to store an integer in terms of memory usage, you need 4 bytes. That's why the address of the second element is greater by 4 than the first. That's the difference between every two adjacent elements. So I hope this video makes it clear to how you can initialize, declare, use, read, modify, access, and so on. Basically how you can do most of the operations using arrays. So this is it for this video, guys. I think we've covered up a lot in a very short time, and probably we are very close to practicing. So have a good day, keep on moving forward, and I'll see you in the next video.